Hello, everybody. We're back with another visual pattern challenge for you. So we've got a visual pattern here, and we've got the step numbers laid out, 1, 2, 3, and 4. And your challenge is to predict how many will be in the next step. So how many in step number 5? How many of these hearts? And then, if you can, how many in step 43? And can you write an equation to model the number of hearts in any step at all? So if you'd like to take that challenge, pause the video and give it a try. All right. Well, let's just look at this pattern first to see if we can figure out what it's doing just visually. Here I see one heart, and then suddenly I've got 4. So that grew pretty rapidly. And actually, right away I'm thinking, is this x squared? Because 1 squared is 1 and 2 squared is 4. Oh, but then I get to step 3, and it doesn't look like a full square. There are a couple missing in that 3 by 3 square. In step 4, there's even more missing in what might have been a 4 by 4 square. So it must be something else that's going on here. Maybe I can get some intuition by comparing step 2 and step 3. So here's step 2 right here, and it looks like we've added 1 on the top left, 1 on this sort of top diagonal, and 1 on the bottom right. And here's that same pattern in 3, and we've just added that one, and that one. Oh, and I guess now it makes sense with this first one. Here's step 1, and we added 1, 2, 3 as well. So it looks like we're adding these 3 every time. Okay, so I think this is going to be a pretty straightforward pattern then. Let's just look at the numbers to make sure we're not missing anything. So I'm going to put the step here, and I'm going to put the hearts here. So in step 1, there's 1 heart. In step 2, there's 4. In step 3, that's 7. In step 4, that's 10. And then actually, let's think about step 5. If we're adding 1 on each of these diagonals, I'd put a heart here, and a heart here, and a heart here, and I would have 13. So in step 5, we'd have 13 hearts. So I think that can be our prediction for the next step, 13 hearts. And when we analyze a pattern like this, we usually look at the differences between the steps. So let's subtract. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. And this should match with what we just saw. We're adding 3 hearts every time, so the difference between the steps should be 3. When you see this difference number staying the same, you know the pattern is linear. So we can use this equation, y equals mx plus b, that's the standard equation for a line in slope-intercept form, to model this. And the slope is actually going to be this difference, this change, this increase in every step. So we're going to say y equals 3x. That's not going to do it though, because here's step 1. If I said y equals 3 times step 1, we put the step number in for x, that'd be 3, and there's only 1 here, so I've got 2 too many. The way to fix that is just to subtract 2, and that would equal 1. So I put that in my general equation here, subtracting 2. So I'm saying y equals 3x minus 2. So that works for step 1, but I should test it with a couple of other steps just to make sure that that's actually working. So in step 2, it'd be y equals 3 times step 2 minus 2. 3 times 2 is 6, minus 2 is 4. Okay, and that matches in step 2. Let's try step 3. Y equals 3 times step 3 minus 2. So that's 3 times 3 is 9, minus 2 is 7. And yeah, we have 7 there. So this looks like it's working. I think we can be confident in our equation here. So y equals 3x minus 2. Now that we've got that equation, we can use that to figure out how many hearts in step 43 by just plugging in 43 for x. So y equals 3 times step 43 minus 2. So let's calculate this. 3 times 40 would be 120. 3 times 3 is 9. So that's 129 minus 2. So we have 127 hearts in step 43. Well, how did that go for you? Did you get that one? Let me know. Thanks, everybody.